Okay, so last class we kind of finished off doing the we finished off with some of these measures of central tendency. So we've already talked about the mode, we've talked about the median, and now we can kind of go on to the mean. So the mean, so it's basically defined for continuous measurement levels. So that would be interval and ratio. But as I think I've already mentioned, if we're dealing with things like Likert scales from 1 to 5, Amazon ratings from 1 to 5, not fully interval, the mean is usually used for these. When Amazon reports a star rating, it's like, 2.5 stars, 3.5 stars, etc., which is the mean. And the mean can be defined as sigma, the sum of I equals 1 to n, where there's n observations, xi, that's just the kind of the counter, all over n. And if this is a sample, it's going to be, we just call this x bar, but do have a note that if we have an entire population, so on a population, this would actually be mu. Okay, so what we want to do is, let's just move my screen up a little bit. So I use the mouse actually, make it easier, as my technology is not working too well at the moment. So let's just have that example we did last class. So we have all these ratings. We have 1, 2, 2, 2. Now remember we had a load of 3s. 3 was the median and the mode. Then we had 2 4s and 2 5s. So x bar is just some of these. So it's just going to be sigma xi. And sometimes you wouldn't even write the I because 1 to n. You know what you mean by sigma xi. And if you remember, we have 13 of n, 13 numbers. So we go 10, 18, plus 15 is 33, plus 6, 39, plus 1 is 40. And that's going to be equal to 3.08 to 2 decimal places. And so that's the mean of that little example. So let's just do a few little additional things. Now, it may be that some of our reviewers are actually more competent and have better reputations than the others. So let's just say we're going to weigh online reviews by kind of reputation. So that might be previous likes of their post, etc. And let's just call these reviewers 1 to 4. So we have reviewer 1. They have a weight of 5. This person has a very high reputation. And we'll call it W1. And they have a score of 9. Reviewer 2 would have a weight of 2. And they would have a score of 3. Reviewer 3, so I didn't put the 2 there, has a weight 3 of 3 and x3 of 5. I should make this actually bigger while I'm here. And reviewer 4 has a weight of 3 and x4 is 7. So you see of these reviewers, reviewer 1 is highly regarded and reviewer 2 is less highly regarded and reviewer 3 in the middle. And these are the scores. So we're going to define a weighted mean, and we're just going to call it weighted x, we'll just call it x bar W equals, and again, we still have n review scores. In this case, it's going to be 4. And it's going to be the weight of I times xi. And we're going to have to divide by the total weighting divided by which is going to be equal to, and we need to do this because we're adding wi times xi, we're adding wi numbers each time, and we remember with the mean we're divided by the number of numbers. So even if some are repeated, we still have that many more numbers were being added. So we divide by the total weight. So let's just what was this for this data set? Well, W1x1 is going to be 5 times 9. W2x2 is going to be 2 times 3 plus 3 times 5 plus 3 times 7 all over the added weights, which is going to be 5 plus 2 plus 3 plus 3, and that's going to be 87 all over 13 equals 6.69. A few little interesting properties of the mean. I remember I was talking about research going wrong, where people have actually found that people's means reported in journals do not have these properties, or something weird is happening with these properties, and this is how they got found out. So this is actually kind of important to think about, that you just understand this a little bit in terms of what exactly a mean is, because you will be reporting lots and lots of means when you do your research. So imagine that we add a constant C to every score which were basically in our data, or the ones we're calculating the mean from. And we want to calculate, what happens to mean. And so let's define our original before we add the score. Let's define x bar 1 is going to be sigma I equals 1 to n. This is before we add the constant, xi all over n. Now we define x bar 2 as sigma I equals 1 to n. And now we're adding c to every single value in the data set. We're still dividing by n. We've not changed the numbers of values, we just added c to it. So say we had 2, 3, 4, and we have c equals 3. Now we would be calculating the mean of 5, 6, 7. And just a hint, the mean of this is 3, the mean of this is 6. You know, what happens to it? What do we add to get it? But we'll work it. It's kind of really easy to work out. And so let's just kind of use our very basic arithmetic. We can kind of distribute these for the sigma, so we can actually plus you see how we did that? We just broke apart these graphics. You can kind of distribute here of this sum sign. So we have xi equals 1 to n, ci equals I equals 1 to n. So ci equals 1 to n, we don't need the 9 because it's the same every time. And then this first bit is just sigma I equals 1 to n, xi all over n. And then the second is just, well, we're adding c. It's the same number each time, n times. So it's n times c. And this is just, again, all over n. And that's just going to be equals to, the first half is equal to x bar, because of our definition we had before, or x bar 1. And the second half, n times c over c, is just equal to c. So the answer is we add c to them. If we add c to every constant to every data, we add c to the mean. Okay, so we know how this works by now. We've got the x1 equals sigma xi over n. But now, you know, what happens if we multiply every xi by c? So it's the same as before, but this time we're multiplying. So x bar 2 equals sigma I equals 1 to n. Then we're going to have basically xi times c all over n. Now, as c is basically multiplied to everything inside this summation, then we can just multiply the summation by c. So we can actually put c, as it's not dependent on the summation sign, we can actually put it to the left of the summation sign. Whoa, I don't think I wanted to do that. Okay. Went a little bit crazy there. So, okay, where were we? So we're going to have sigma I equals 1 to n. So C times, we'll just put a times there, or C, I equals 1 to n xi, all over n. And, you know, if we have this area here, just let me change the color. You can see this is going to be C multiplied by x bar. So this is just going to be C times by my x bar 1. So the answer here is we would multiply, if we multiply every xi by C, we multiply x bar by C. Okay, so before we finish means, I've got a few just interesting means to get you thinking about means. So let's have a scenario. And there's other ways of doing this. We can standardize scores and things like this, but this is actually kind of an interesting little thing. So I'm just going to put this section, I'm just going to call it a little craziness. I'm not going to ask you to calculate like one of these weird means on the exam. Oh, it turned my line into a beautiful straight line. I'm impressed. Okay, so a little craziness. So imagine we have some movie scores, and I've got, you know, me and my bad movies again. So we've got Alone in the Dark. I've moved on from Troll 2 as my favorite bad movie, and we've now got Alone in the Dark, starring someone called Tara Reid. And this is not a good movie either. And basically, we've got we're giving it a star rating 1 to 5. So let's just have a look about. We've got some reviews from different sites. So I think one might be Amazon. So we have the scale. On the scale of 1 to 5, it's been given a 1. On a scale of 1 to 10, so we've got, this is IMDb. It has 2.3. And on 1 to 100, it has a 1% on Rotten Tomatoes. I'll just call that RT. And it has 9% on Metacritic. Those marketing students, if you're doing social media work, these are just movie review websites. Metacritic is for people actually, you know, the average Joe, the average person watching can actually comment. Rotten Tomatoes, oh, a bit more room. Is basically an aggregation of all kind of commercial reviews. So how do we, you know, like find an aggregate rating of these? Now, I said one thing we could do, but we've not covered any of this stuff yet. We could standardize the scores. If we were to calculate an arithmetic mean, then the Rotten Tomato score and the Metacritic score would actually have much bigger weight because they're on 1 to 100, while the others are on like 1 to 5 and 1 to 10. So the nice thing about we're going to do the harmonic mean is we multiply values. No, sorry, this is I'm getting confused. This is the geometric mean. I was getting ahead of myself. So the nice thing about the geometric mean is we multiply values. And here we define, I'm just going to call this x bar g. And it's going to be the product of I equals 1 to n xi to the power of 1 over n. Product just means we multiply. If you've not seen that sign before, we just multiply everything together. So this is equivalent to the root of this, and to the power of 1 over n is just the kind of the nth root, shall we say, the nth root of the value, and multiply x1, x2, all the way through to xn. Okay, so let's look at my movie example. Is going to be 1. We just multiply them together times 2.3 times 1 times 9 to the power of 1 over 4 equals 2.1333. As I said, multiplying, it does kind of depend a little bit on the variation, but it doesn't account for scale quite as much as the arithmetic mean. In here, like Metacritic and Rotten Tomatoes won't completely overload, for example, IMDb in a scale of 1 to 5. Okay, and my next little mean is the harmonic mean. And what this is, I'm going to call it harmonic. I'll call it x bar h. And this is basically equal to n all over sigma I equals 1 to n. Sorry, I equals 1 to n. 1 over xi, i.e. n over x1 to the minus 1 plus x2 to the minus 1 plus xn to the minus 1. And the thing is, what this does is it actually, if you have an outlier, then this, this is relatively robust to outliers. And let's just say I have number of miles. And I've got 5, 3, 2, 4, and 100. And maybe I just went a little crazy that that week. Or perhaps I was supposed to type in 1 and I typed in 100. And if I've got some sort of algorithm, fitness algorithm, it might go completely off if it has 100 rather than 1. My x bar, my standard x bar, my x bar arithmetic would be 5 plus 3 plus 2 plus 4 plus 100 equals 22.8. So that 100 really drags it upwards. But my x bar harmonic is going to be n5 over 1 over 5 plus 1 over 3 plus 1 over 2 plus 1 over 4 plus 1 over 100. You see this large value doesn't have, has relatively less influence. And that's going to be 3.87. Okay, so those were, we might actually come across the harmonic mean later in the class. There's 1 or 2 applications in statistics. But it was just a bit of, I just wanted to get you thinking a little bit more about means with this idea of the weighted means and these different types of means. Geometric mean, how it you know, good for comparing across scales, harmonic mean, how it deals with outliers, and then the weighted mean, which has some applications where you have more confidence in some of your information than in other parts of the information. Okay, and we'll kind of have a, I'll just break the video there before I move on to the next section.